Okay, the recording has been started. Right. So yesterday we have discussed about the difference between manual testing versus automation testing. I will give you a quick recap. Right. So by definition, when you execute test cases manually without using any tools, right? It is called as manual testing. When test cases are executed automatically. So automatically, in the sense, uh, tools will come into the picture. Tools like Selenium will come into the picture. By using the Selenium tool, you can run the test cases automatically, and it is called as automation testing, right? And we have discussed about the speed. So literally, automation would be much faster than the manual because there is no human intervention, right? So that's why automation is much faster than the manual testing. Accuracy, of course, automation, is more accurate because manual testing. So humans are tend to make mistakes, right? So errors are common sometimes. So automation, there is more weightage on automation. And cost wise, initial cost manual is going to be low. Initial cost it is going to be high, but on the long run, the cost is very much effective in the long run. Automation and reusability we have discussed, right? Reusability we have discussed the best use cases, and human observation also we have discussed, right? And when it comes to tools, manual, no tools are required. You just document it by using Excel sheet. Documentation has to be done manually. Documentation needs to be done manually, right? So automation means requires tools like Selenium, TestNG. Those we are going to discuss each and everything that I have shown here, right? So maintenance wise, let's setup is going to be very rich for manual testing, and for automation, you need to create some scripts for the maintenance, right? And reporting, testers write reports manually, so automation tools generate detailed logs and reports automatically. So we have concluded this, and also we have understood about the architecture. So yesterday I have shown you the architecture in the eye level diagram. The same thing I have done here, right? So you have the browser, right? You have the front end layer. You use languages like HTML, CSS, JavaScript, right? And the back end layer is going to have Java, Python, and .NET to write the business logic, and you have the database layer. So where exactly the Selenium tool is going to fit? Where exactly Selenium fits? Selenium is going to fit between the client layer and the front end layer. So this is where exactly the Selenium is going to fit. I will share you these notes. Okay. This was all about the basic introduction of the Selenium course, right? So today our agenda is we are going to understand the class 2. I am going to give you a brief introduction about the Java programming language, right? Then we will start writing some programs. We will understand some concepts. Then we will jump into Selenium tool to understand how we can install the Selenium tool and all. Okay, are we good? Type S in the chat box, everyone. Can we proceed? Everyone type S in the chat box. Are we on the same page? Ganesh. Okay then. Okay. So the topic, this is going to be very interesting, right? So before understanding Java, we will understand what is a what are the types of programming language. So in the industry, okay, in the computer world, there are about 1,000 programming languages. Approximately, there are about 1,000 programming languages. The numbers may be more or maybe less, but approximately there are about 1,000 programming languages in the computer world, right? But each and every programming languages is going to be categorized into some types. Yet in this example, so if I want to categorize the programming language into types, this can be categorized into three types. One is structured programming language, right? Second one is object-based programming language. Third one is object-oriented programming language. right? So C and Python comes under structured programming language. I will tell you what is structured programming. So this is a category. So this is a kind of principle that these programming languages are going to follow. So they have adopted this principle. They are adopted this principle, or they are adopted this paradigm. Which one? C and Python, right? Likewise, object-based programming languages, right? Visual Basic, VB Script, Python. They have adapted this object-based programming language type. This is one of the type, right? So each and every type is going to have some set of rules and regulations. So they have adapted this programming language, or adopted this type. Likewise, you have object-oriented programming language. So Java is coming here. Java is coming. If in the interview room, if anyone is asking, what are the types of programming languages that you see? Okay, we can simply say there are three programming languages, three types of programming languages. One is structured programming language, object-based programming language, and object-oriented programming language. So these are the examples. These are the popular programming languages I have given as an example. But if you see Python, you can call Python as structured programming. It can be object-based programming. It can also be object-oriented programming. It has adopted these three features. Whereas Java, when someone is asking what type of programming language is Java, you should say Java is object-oriented programming language. Okay, what is the takeaway here? The takeaway is very, very simple, right? If any programming language that follows all OOPS concepts, so these OOPS concepts are listed here. So what is OOPS again? Object-oriented programming. Any programming language that follows all these OOPS concepts: class, object, okay, polymorphism, inheritance, encapsulation, abstraction. So they comes under object-oriented programming language. Right? So this object-oriented programming, the C++ follows all the OOPS concepts. Java follows all the OOPS concepts. Python follows all the OOPS concepts. These are follows all the OOPS concepts. Right? If any programming language follows only class, object, okay, encapsulation, abstraction. They are called as object-based programming language. In the object-based programming language, they just follow, they just write a code based upon the class, object, encapsulation, and abstraction. Don't worry about what is a class, what is object, what is encapsulations. These are futures. These are futures. These futures are adopted. These futures are adopted by object-based programming language. Likewise, when any programming languages that follows all the OOPS principles, OOPS concepts, right? So what are they? Everything like class, you have object, you have polymorphism, okay, inheritance, encapsulation, and abstraction. They are object-oriented programming. If any programming language this does not follow these OOPS concepts, they are called a structured programming language. As simple as that. Interested so far? No? Structured means it does not adopt use OOPS. What is object-based programming language? It has adopted features like class, object, encapsulation, abstraction. What is object-oriented? It has adopted features like what? Class, object, polymorphism, inheritance, encapsulation. Are you good so far? Type us in the chat box. So this is a bit theory I am going to give, right? Practically, it is going to be very interesting. Are we good so far? Yes, no? Are able to follow? Someone say something in the chat box. Yes, yes. Keep the session interactive. Good. Okay. Now see the picture, right? So this is very important. So we have C, C++. Let us understand the basic difference between the C, C++ versus Java, right? So what does the theory says? C, C++, they are dependent. Dependent in the sense they're platform dependent programming language. They run only on, they run single application at a time. What does it really mean? So this, you come across this word very, very often in the interview room. You come across this word very, very often in the interview room. Something like this is the theory. C, C++ versus Java, right? So C, C++, they are platform dependent programming language. So whenever you write, okay, a simple program by using C language, right? Let us say you have written a simple code by using which language? By using C language. C language. A code has been written by using which language? By using C language. So usually, let us assume that, okay, now focus here, this is very, very important. Let us assume that you are using the Windows operating system. Windows OS, Windows operating system, to write your C programming language, right? You're using the Windows operating system to write the C programming language, right? As soon as the code is written, what you usually do is, in every programming language, you perform the compilation. You perform what? You perform the compilation. So you need to save the code that you have written. So in order to save this, let us say that text dots. This is how you save your C code, right? And you perform what? You perform the compilation. For the compilation, you use something like there is something like C engine. Okay, compilation is nothing but it is a kind of what compilation will do what? It will check for syntax errors. It will check if the code is organized or not, if the code structure is followed or not. If it will check for syntactical errors basically. As soon as you write the code in the in the notepad or something, right? You use the C language, right? You need to give this piece of code to the compiler, right? In this case, it is what? It is a C engine. Okay. This C engine will convert text.c to, it is going to convert what? Text.c to text.exe, right? And you give this code, okay, you will execute this code. This code will get executed, okay? This code can be executed only in the Windows operating system. I mean, this is very specific to Windows operating system. You cannot execute this. You cannot transfer this file to any other operating system for the execution. For example, let me take, let us assume that I have one more operating system like Mac operating system. Mac operating system, right? So the code has been written in the notepad. Okay, I have used the C engine. The C engine, okay, this code has been written in the Windows operating system. The C engine is also there in the Windows operating system, which has generated the executable file, which is text.exe, right? So you can see the output. This can be executed only in the Windows operating system because you have used the Windows operating system to write the code, to compile the code and to execute the code. So you will get to see the output only in the Windows operating system, right? If you just transfer this .exe file to the Mac operating system, it will not execute. This is called as what? Platform dependency. Okay, you can write code, you can compile in the same operating system. Okay, that is called as what? Platform dependent programming language. Compilation can be done in the same operating system. Okay, if you want to use another operating system, you need to do the recompilation once again. You need to recompile it once again. Okay, how we can recompile it? You can take the same piece of code, right? So in this new operating system, you can take the same piece of code once again, right? You will be compiling it in the Mac operating system, so which is going to have the C engine. It is going to generate what? It is going to generate the text.exe file, which is specific to Mac operating system. Okay, you write C code in the Mac operating system, you compile it in the Mac operating system, and you execute this in the Mac operating system. So this text.exe file is specific to the Mac operating system, right? That's why the C programming language is called as what? Platform dependent. They are dependent on, you can write the code in the same machine, and you can compile in the same machine, and you can run the same machine. Okay, you cannot transfer the executable code to another operating system. It is not possible. That's why we call it as what? The platform dependent programming language. They run single application at a time, right? So this is what it says. Okay. Now, so since we have to understand about Java, we are understanding about the Java futures, right? So let us understand the Java thing. Java is a platform independent programming language, completely opposite to C and C++. Java is platform independent programming language. What is actually happening in the Java? Why Java is called as platform independent? Let me take the same example. Okay. Why Java is platform independent programming language? Let us say that I have a piece of Java code. I'm writing a Java code. Okay, this is simple Java. Okay. Let us say that simple Java. Don't worry about this code. I will explain you. I'm saving it as test.java. Okay. I'm writing this code by using what? By using, let me use the Windows operating system itself. I'm writing this piece of code in the Windows OS. Right. After writing this code, I need to perform the compilation. So the compiler will come into the picture. The job of the compiler is to do what? It will check for syntactical errors. If there are any errors in this code, the compilation will not happen. It will check, okay, the code has been perfectly structured or not. The code is completely organized or not. The code should not have any errors. If that is the case, it will compile the code. After the compilation, the text.java becomes test.class. Right? After successful compilation, the text.java file will become text.class file. Okay. Then what happens? To execute this code, you will use the JVM. There is a machine called JVM. JVM is nothing but we'll see what is JVM. Typically, we call it a Java virtual machine. Right? You give this test.class file to the JVM. JVM will give the output. Output will be generated by the JVM. So this is the flow. Okay, this is the code that you have written. Text.java. Right, the code that you're writing. I have just saved it with the extension .java extension test.java. After writing this, you give it to the compiler. You give it to the compiler. Compiler will convert the text.java to text.class file. After this, you will send this test.class file to JVM. Okay, JVM will start executing the code and give you the output. Output will be generated. Right? The question is, why Java is platform independent programming language? Why Java is platform independent programming? Okay, if let us say that you are having another operating system. Okay, let's say that I am taking I'm taking the Mac operating system here. Okay, Mac OS. Right, you can transfer this test.class file to the Mac OS system till the output will be executed. Right, you do not have to recompile it again. That is the only difference. In the above example, okay, you have to recompile it every time if you want to use the if you want to execute the code in a different machine or in the different operating system, recompilation should be there. You should always recompile because of the platform dependent nature. But in this case, you do not have to recompile it. The code that is being generated by the compiler, which is called as the dot class file, you can just send this dot class file to the different operating system without having to recompile it. The output will be generated. It's going to generate the output by using the JVM. You are avoiding the recompilation. Hope you're able to understand. The only basic difference is the previous dependent C nature, you have to recompile it. Here you don't recompile it. That is the only difference. Okay. No need to recompile. Compile, you can directly use the dot class file. Dot class file which was generated in another OS to execute in another OS. That's why it is called as what? Java is the platform independent programming language. This is the only thing. So shortcut you can say okay, WORA. Okay, please remember this word. WORA means write once, run anywhere. Okay. I hope you are able to understand what is platform dependent and what is platform independent. Let us go jump into the next thing. Okay, it is Java is object-oriented programming language. We have understood this because it is following all the OOPS principles. It has adopted all the OOPS principles like class, object, polymorphism, inheritance, encapsulation, abstraction. We are going to see these things in detail. What is the next one? It is a case-sensitive programming language. Java is a case-sensitive programming language. What does it really mean is, I will send this picture to you, your email address. Case sensitive means when you have a variable like x equal to 10, okay, and capital X equal to 10, right? So this both x will be treated differently. This x is not same as this x, right? So it is strictly case sensitive. Okay, likewise, Balaji equal to something like, let me say 100, okay, or 100. Okay, by pronunciation it is Balaji. Okay, but Java will treat this Balaji as a different variable, this Balaji as a different variable, this Balaji as a different variable. Why? Because you can see there is a mismatch in the cases. Okay, it is starting with capital letter and are small letters. Here everything is small letter, different one. Here the first letter is capital and the consecutive letters, the A is also in caps. So each and every variable will be treated as a different. That is why it is what case sensitive programming. No explanation required. The very important point, it is open source. When I say open source, it is supported by the community version. Open source means it is available for free. Java is available for free. Anyone can download, anyone can use it to develop applications, right? Okay. So you do not have to pay anything for that. It's available for free, right? So it is supported by what? Oracle Corporation. Open source is called as what? It is available for free. It is free of cost. You do not have to pay anything for this. Okay, that is one of the main features, right? It is more secure. Why it is more secure means, you cannot Java code cannot be broken very easily. Okay, when you write a piece of Java code, right, and hackers find it very difficult to inject any kind of malicious content. It is very difficult to break the logic. right? For now we don't have to think about the security. On the long run you will understand why it is more secure. Okay, just remember this, it is more secure. And I can also say that it is more secure than any other programming languages, especially when you compare Java with Python, right? Python lacks security. Okay, Java overweights Python because of the security. That's why Java is preferred for what? Java is preferred for banking applications. Most of the banking applications they prefer Java programming language because of the security reasons. Here Java is overweighting Python. Okay, it is architectural neutral. If you want to understand architectural neutral, okay, let me give you a small example. What is architecture neutral? You understand this? Focus here. The platform independent and architectural neutral both are almost same, but there is one little difference. Okay, you need to catch that. Okay. So what is an architecture? When I say an architecture, with respect to programming languages, right? When I say architecture, not the civil architecture, with respect to software or with respect to any programming language, architecture means combination of hardware components plus software, right? Or combination of hardware and software. So hardware means I can say that you can consider the RAM. Let us say that the RAM is capacitor RAM is 4 GB RAM, 4 GB RAM. Let us say that the processor is Intel. Okay, let us say that the hard disk size, right? Hard disk size is something like 500 GB, right? These are the hardware components, and software components you can include the operating system, something like Windows OS system. Okay, so this is an architecture, right? Let us say that you have purchased the computer, today, or let us say that you have purchased this computer, like let us say that this is Lenovo. You purchased it in the year 2015. For some reasons, you find right, the computer is running very slow. Computer is running very slow, and it is taking a lot of time to give response. If you click on any button, it is taking a lot of time for the response, and you found that reason is because of the 4 GB RAM. What you have decided? You have decided to upgrade this. Upgrade in the sense you want to you want to upgrade the hardware as well as software. Okay, what you are trying to do, instead of using 4 GB RAM, you're trying to change the architecture. You're trying to upgrade the architecture. So this combination is called as architecture, right? You just want to do what? You just want to upgrade the architecture. Upgrade in the sense 4 GB RAM. You are changing the 4 GB RAM to 8 GB RAM. Upgradation. You're scaling it. You're doing the vertical scaling. You're just increasing the hardware components. Increase the capacity of the hardware components. Instead of Intel, you're preferring Ryzen. Instead of 100 GB hard disk, you're preferring 1 TB hard disk, right? And software, instead of Windows 7, you preferred Windows 10. Okay? You did the vertical scaling. You did the upgrade. From the lower architecture to higher architecture, right? And so when your Java program, right? When you have a Java program, let's say this Java program, okay? You do not have to change anything for your Java code. Java code works perfectly on any architecture. No matter what are the combination of hardware or the software, right? You do not have to make any changes to your code. If this works fine. This is working fine with the old architecture. This will also work fine with the new architecture. Okay, Java is not like I will be working only on so and so architecture. It's not like that. You can work on any architecture, any hardware, and any software combinations. That is the reason why Java programming language is preferred in mobile applications as well. Because hardwares are completely different in the mobile phones. It will work there as well. You can develop mobile applications. can develop web application. That much flexibility is there. This terminology is called as what? This is called as what? Architectural neutral. Are you able to get what I'm trying to say? Can I get yes from the chat box? Everyone? Yes, no? Have you understood what is architecture neutral? Right? Good, good. Everyone respond, guys. If you have any doubt, you can hold me and ask. Okay. Now look at this. And this is the reason why I'm saying the architectural neutral is completely different than platform independent. Platform independent, right? Just remember this. Platform independent talks about the operating system. Talks about OS, operating system. Architecture neutral talks about what? Talks about architecture. Architecture is combination of hardware and the software. Okay, perfect. The next one. And now look at this. It is portable. Okay. When I say portability, you might have heard what is the portable a long time back. Okay, we used to port the SIM card, right? You keep the same number, but you can change the service provider, right? SIM cards are very much flexible nowadays. Your phone numbers are very much flexible nowadays. You do not have to stick to the specific service provider. Instead, you can retain the same number, but still you can able to do what? You can able to change the service provider, isn't it? Likewise, when I say portability, okay, portable is just like the architecture neutral. Okay, but you instead of dealing with one machine, you deal with different machines. Right? Instead of dealing with one machine, you deal with different. Here, what did I just say? Here we are upgrading it from Windows OS Windows 7 to Windows 10. Windows 7 to Windows 10. Right? So when I say portable means, let me copy this. When I say portable, okay, so portable means you have two different machines with two different architecture. Okay. So this is Lenovo. Let us say that this is something like Intel, right? So instead of Windows OS, you might be having a different OS. Let us say that okay. Let me say this is Mac operating system, MacBook, Mac. Okay, let us say this is Mac, right? Let us say that you're using Mac OS, not the Windows one. Or software is Mac OS. Okay, so you have different hardware structure here with respect to Mac OS. You have different hardware structure here with respect to Windows 7 OS, right? The Java code that is working here in the Windows OS with a different hardware structure. Okay, it will not be affected when you move this Java code to the Mac OS with different hardware structure. I mean, you can easily port it. You can the same piece of code without making any changes with respect to the software and hardware, right? You can easily move it without making any changes. The same code can work across the platforms here and there. Okay, architecture neutral is the same computer you are upgrading your vertical scale, you are scaling it vertically. Please understand the difference. It's in the same computer, you are scaling it vertically. You are increasing the capacity of the hardware and you are updating the software. But the software is same. Windows OS software is very much same. Windows, you're not changing the software, right? You're not changing the software is same, but you're giving an update. You're updating it from 7 to 10, and you are increasing the capacity of the hardware structure within the same computer. Okay, the same piece of code without making any changes, it can work. It can work. No, you do not have to make any changes. Architecture neutral. Here, okay, more or less than like the same thing only, but you deal with two different systems. One is Lenovo, second one is MacBook. Okay, different hardware components and different the software components, different hardware and different software. The code that is written in Lenovo without making any changes, the same code can be used here. It will work across the platforms. This is called as what? Portability. Right? So small differences, sir. For these three things, for the platform independent and for the architectural neutral, we can include this Vora. So what is Vora? Write once and run anywhere. Okay, same thing applies for this also. If anyone is asking you the question in the interview room, okay, remember this word Vora for portability, for architecture neutral, for platform independent, and you can explain the things which I have just explained. Okay. Last one is multi-threaded. So for now, remember the multi-threaded, like you can perform at any point of time. Okay, at any point of time, you can perform task parallelly. At any point of time, you can perform task parallel. If you have something like if you have three tasks, okay, let us say that this is task 1, task 2, task 3. Okay, T1, T2, T3. Okay, at any point of time. Can be, let's say that the time is something like you know 8:20. The same time you can perform many number of tasks simultaneously at single point of time. Multi-thread at single point of time you can perform different tasks simultaneously, so that performance will be increased, time consumption will be reduced. That is called as what? Multi-threaded programming language. It is possible in Java. Okay. The same thing that I have given here, right? I have given here, right? Architecture neutral versus platform depends in Java. This is the theory. I will send it to you. I will add these notes in the description in the YouTube. You can take it from there. Okay, and what is platform independence? Everything is written here clearly, right? Okay. Now the next thing is components. Okay, these are very important. Components of Java. Okay, your component like JDK. JDK stands for Java Development Kit. JRE stands for Java Runtime Environment. JVM stands for what? Java Virtual Machine. Okay, let us understand what is this, what are the components and what is the JDK, JRE and JVM, right? So this is very important for the interview room. Let me save this. Okay. What is it? Components of Java. Okay. So the component Java. So whenever you download the Java from the Google, right? Whenever you download the Java, let us say that this is a Google. Okay, you want to download Java. Download, right? As soon as you perform the download action, you will get a package. I mean, you will get a kit, like in the form of folder. Okay, Java. This is called as what? JDK. Java development kit. Right? What will be there in the Java development kit? What are the things that you can find in the Java development kit? Right? Typically, this Java development kit is used by the developers. First very important point. JDK is required for the developers. Okay, JDK is required for the testers because this is the environment where you can develop Java and where you can test the already developed code. Okay, whenever you are downloading the Java from the Google, right, you will be downloading it, it will be downloaded, right, you will get the JDK is more Java development kit, right. So this is how the JDK looks like. Okay, this is how the JDK looks like. Java development. Inside the Java development kit, you have two important components. One is what? One is the dev tools. Dev tools. Inside this dev tools, you have tools like Java C. I will tell you what is Java C. You have tools like Java. You will be having tools like Java P, and you will be having many tools, but you do not use those tools directly. This will be used internally. You will be having development tools like Java C. Okay, let me put it outside. You have development tools. Along with that, you will also be getting something like JRE. So JRE is subset of what? Subset of JDK. What is JRE? JRE is Java Runtime Environment. As I've already said, JDK is used by, JDK is necessary for developers and testers. But what about JRE? JRE is called as, JRE is an acronym for Java Runtime Environment. It is necessary to run the developed Java code. To run the developed Java code. The code that has been developed by the developers, it needs to be run on the platform, right? To run that, you require what? You require an environment that is called as what? JRE. This is called as what? Java Runtime Environment. So it will run the developed Java code or already developed Java code. Okay. Who is going to have this JRE? Who has to download this JRE? Okay, it is necessary for the clients. It is necessary for the clients. Okay, if you when you download Java, you can download JDK. At the same time, the clients, okay, who is going to run this application, they don't download JDK directly. Instead of JDK, you also have an option to download JRE from the browser, from the Google browser. You can just download JRE. Okay, either you can download, developers download JDK, clients download JRE. Okay, so JRE, this is how the JRE is going. JRE is the subset of JDK. Inside the JRE, you will be having the Java libraries. Very, very important Java libraries you will be having. Okay, along with the Java libraries, you will have a component called JVM, Java Virtual Machine. Okay, so we got to know JDK. So when you download JDK, you will get what? When you download JDK, the developers has access to dev tools, right? Okay, and they have access to JRE, they have access to JVM, and they have access to Java libraries. So this JDK is meant for developers. And when the clients download JRE, right? They have the JRE, they have inside that they have JVM and they have Java library. So JRE is the subset of JDK. This is the subset of what? Subset of JDK. Subset of JDK. JRE. So this is for developers. Okay, this is for clients who want to do what? Who want to run the application, run the developed application. Then what is JVM? Okay, JVM is called as what? The Java virtual machine. Okay, it will execute the dot class file. JVM is an acronym for Java virtual machine. It executes the dot class files. Okay, I will tell you the simple to understand this better. I'll tell you. So you cannot download JD, you cannot download JVM directly from the Google. JVM is part of, it could be part of, it could be subset of what we call it as subset of JRE, or it could be the subset of JRE, it could be the subset of JDK. You cannot download it standalone. You have two options to download. Either you can download JDK directly, you can download JRE directly, but you cannot download JVM. JVM is the internal component. It is not something like you can get it directly. This is a subset of JRE or the subset of JDK. Right? These two things you can download. Right? Then what is the use of this JVM? We will understand what is this dev tools, what is this dev tools, and what is this JRE, what is this JVM, what is this Java library. We'll understand one by one. Right? Very simple. Whenever you're writing a piece of Java code, okay, so after downloading Java, okay, we are developers and we are testers, right? After downloading JDK, right, you will have an option to, you can start writing a Java code. Let us say that this is my simple Java code. Okay, my Java code is like, let me take class A. Don't worry, what is a class? A simple pseudocode I am taking. Okay, or you should always save the file with the .java extension. Right? Let me save it like, you have to save it like, for example, if your name of the class is here, so this is the name of the class. If for now, try to understand, this is the name of the class. The name that is followed by class is called as the name of the class. A is the name of the class. Okay, you have to save it like class name.java, which is what? A.java. Okay, this piece of code will be written in a notepad. Okay, assumption, notepad, right, in your system. After writing it, okay, you need to compile it, right? You need to do what? You need to compile it. Okay, to do the compilation, you should be using what? This particular Java tool, which is Javac. Okay, this is already there in the Java development kit. You need to, when you want to activate, say there is something like a compiler in your Java JDK. There is something like a component called compiler. The job of the compiler is to do what? It will check if there are any errors in your piece of code. It will check each and every line. Okay? If the code that you have written is completely perfect and all right, it will start compiling it. I mean, compilation is the generic process. It will check for syntactical errors. It will check for spelling mistake. It will check everything. After the successful compilation, okay, it will generate a .class file. To activate this compiler, to do what? To activate this compiler, right? You use this Javac command. Okay. So this Javac command is part of what? Part of development tools that is already there in the JDK. You activate it by saying command like Javac. When you say Javac, compiler is activated. After activating the compiler, what you also have to be very much specific that you need to compile this a.java file. Okay, Javac command is going to do what? It is going to activate this compiler. Okay, and what you want to compile? You want to compile a.java file. Okay, that you are specifying it here. Because of this command, okay, this a.java file, okay, will be consumed by the compiler. Okay, the compiler is going to generate what? The compiler is going to generate, after the successful compilation, is going to generate a.class file. Okay, so you are using these tools to do this action. You are using this Javac tool to do this action. After getting the a.class file, okay, a.java file is converted to what? A.java file is just converted to a.class file, right? then you want to activate the JVM, you want to activate the JVM, so that you will be getting the required output. JVM is here, right? So to activate the JVM, you will use this development tool command, Java command. Okay, just use Java command. When you say Java command, the JVM gets activated. JVM gets activated, right? Then you need to be very specific. Okay, which dot class file you want to execute. Okay, you should say a dot class file, which has just been compiled. Okay. The moment you say this a dot class file will be consumed by JVM. Okay, it will execute the code and it will give the output. You get the output. This is the flow. This is the typical flow of a particular Java program. Right? You write the piece of code in the notepad, right? So the moment you are downloading Java development kit, okay, JDK. Why JDK has development tools, right? So it has so many tools. That is for the purpose. There is a purpose for that, right? And you have the JVM in the runtime environment. If you see, you can separate this. This part is taken care by JRE. And the combination of this part as well as this part is taken care by what? JVM, JDK. So I can just conclude that if anyone is having JRE, they can just what? They can just do what? They can just execute the already compiled Java code. They can just execute the already compiled Java code. If anyone has JDK, they can write Java code, they can compile it, they can send it to JVM, and they can execute they can generate the output. These are the steps. First step is what? Write the piece of code, okay, in the notepad. Second step is what? Activate the compiler, right, by using Java C tool, okay, and give the .java file, okay. Then compiler will check the syntactical errors and it will generate what? It will generate the dot class file, a dot class file, right? And the third step is activate the JVM, okay, and followed by give the dot class file name so that this dot class file will be consumed by the JVM. Okay, JVM will process and will generate the output. Okay, so clients are going to download the JRE so that they can consume the dot class file and they can see the output. But developers, they need to download the JDK. So this is the flow. Okay, now you might have got some idea what is JDK. JDK is simple. Keep it very simple. JDK is Java development kit, right? Developers will be using this. Developers or testers. What is JRE? It is going to run the already developed code by the developers. So this is going to be used by clients. Okay, what is JVM? It executes the dot class files. Isn't it so? JVM is just executing the dot class file. So it is just consuming the dot class file and generating the output. Okay, these are the components. When someone is asking, hey, can you tell me what are the components of Java? What do you would say? There are three components of Java. One is JDK, JRE, and JVM. What is JDK? JDK stands for Java Development Kit. It is used by developers and testers. What is JRE? Java Runtime Environment. It is used by clients. What is JVM? JVM is Java Virtual Machine. It executes dot class file. As simple as that. Right? So understanding JDK, I have given the theory as well. I will be attaching this in the description. What is JDK? Java Development Kit. Okay, everything what I have just explained, that is over here. Needed to write, compile, and debug Java code. JRE, subset of JDK, used to run Java programs. Include JVM and JRE Java libraries. Does not contain development codes compare. What is JVM? Part of JRE, converts bytecode. Bytecode is also called as dot class files into machine code at runtime. Ensures platform independence and memory management. Okay, you write a code. Okay, if let us say that the flow is like hello world .java. The file name is hello world .java. When you activate the compiler, after compilation, it becomes hello world .class. You give it to JVM, you get output like hello world. Right? So tomorrow we will see the installation steps, how to download JDK, and we will also download the Eclipse so that we can write our first Java program. and we will start understanding about the classes and methods.